And finally, will you guys tell me what do you think denominator is? That is something we're familiar with. We did it before.
Oh, yes.
Vitaly.
Sorry. It is the bottom part of your fraction of the 1 on 1 is going to be
Exactly. That's correct. Okay. I'm not gonna write it down because we're running out of time. So what are we gonna do now? We're gonna learn something completely different. Before this, you guys learned about adding fractions that have same denominator. So for example, 2/4 plus, let's say, 3/4. And you guys done it before, so you know. Today we're gonna be learning completely new concept of adding fractions with different denominators. In order for us to learn it better, this can help. What do you think it is? Do you know what it is?
Eggs.
Eggs. Okay, a good guess. But there are no eggs in it.
So it's just the carton with colors.
Okay, excellent. This is the carton with colors. I want you guys to go ahead, take this few minutes and divide each part of the carton into same parts. So for example, if you see this two, they're the same part.
Okay.
Yes. So take a few minutes.
These are all really small parts.
So by going by color or amount of
By parts. You go in by parts. So equal parts come together.
looks like colors match
So-
the parts.
Yes. Since there are 12 pieces, is that going to make the bottom, the denominator 12?
Might be. We'll talk about it. That's a very good observation, Vitaly.
I know. These don't stack very well.
It's confusing because they're the same color, but they're different.
That's the tricky part about it. They could be different colors. They could be looking different, but they could still represent the same fraction.
Well, see, like we have two halves with different colors. Okay. You're tricky.
That is the point of this.
There goes good. Vitaly?
There we go. Okay.
Excellent job. That was really quick, you guys. So let's talk about the whole. So I want you guys to talk to each other, take a minute, and name me the whole of the entire egg fraction set. What is the whole?
I think when we look at these, the whole is going to be this because it is just one piece.
It is. It's the only one that hasn't been taken apart, yes.
Okay, so you guys decided which one?
Yes.
This one? Why?
When we were talking, this is the only fully put together carton.
How would you represent it in a fraction?
This would be one piece over the one piece, which is the carton.
Any other ways you can represent it as a fraction?
Well, I guess if you really
Think about the amount of eggs that can fit into the whole.
12.
12.
So if there's 12 spaces for the eggs, and if
Exactly.
there's 12 eggs, it could be also 12 over 12.
Exactly. Which equals to...
Not bad.
the 1 over 1, not 2 over 4 plus 3 over 4.
Well, yes, I will have to erase this. So if we reduce it, it's going to equal to what Vitaly said before, 1 over 1. So it's the same thing, just two different numbers. Okay, what I want you guys to do real quickly is to find half piece of an egg carton. And tell me what fraction it is. Talk to each other, you can work together.
So you have 6 spaces?
Yes.
I also have 6 spaces. I don't think the shape of it matters.
No.
But it's still...
But it's still half of the carton.
Right.
Okay,
Yes.
you guys decided this is your half. How would you represent it in a fraction?
Well, if this is going to be the one piece, but there are 2,
Right.
this is going to be 1 on top is the numerator, and 2 on bottom because there are 2 pieces.
Okay. Good, very good. And now I have a question. You both hold different shapes, but how come you say they're the same?
Well, both shapes would hold 6 eggs.
That's right.
That's the way I think about it easiest, is how many eggs the spaces would hold.
Exactly, exactly. So you guys are both correct. So now find me 1/4 or fourth part of the egg carton.
Of the whole?
Of the whole, yes.
1/4.
Yes, when I say egg carton, it also means a whole.
6.
A whole. That's the one. Okay, how would you represent it in a fraction? I kind of gave away to you guys, but if you remember.
Again, it's easy for me just to count the spaces, so I would say 2, 3 over 12.
3/12.
3/12.
Okay.
But I don't know if that can be changed at all.
Well, what do you think? Vitaly, do you have any ideas? Can that be changed into something?
Well, I know that 3 times 4 is 12, so could you divide both the top and bottom by 3?
Exactly. That is exactly right. So if we divide the bottom and the top by 3, what will we get? 3 divided by 3, what is it?
1.
1. And 12 divided by 3? How many 3's goes into 12?
4.
4, there you go.
Yes, 4.
So we end up with 1/2 plus 1/4. And now the big question.
Where
What?
did the 1/2 come from?
It was the half piece.
Oh, from before?
Yes.
I see, I see.
Yes, yes. So the big question is, when we add these two pieces together, what will we get? Before you only worked with fractions that have the same denominator. Now we have completely different denominators. So how do you think you guys can find the answer? Using the egg fraction carton stack.
Well, if I put together the 2 pieces I was using, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 over the 12 that it takes to make a whole.
Wow, that's very good, Vitaly, very good.
I got the same thing too, with 2 different shapes.
Two different shapes.
Same amount of spaces for the eggs, but just different in shape.
So when we use egg cartons, the easy way to find the addition is when you count the spaces or how many eggs can fit. So that's what both of you exactly did. You counted, you added together. So you had 1/6 piece that can hold 6 eggs in it, and you had 1/4 piece that can hold only 3 eggs. So it can hold a total of 9 eggs, and since the whole is 12, we get 9/12. Now tell me, can this be reduced like we did over here with this one? And how would you do that, Vitaly?
Well, I know that 9 and 12 can both be divided by 3.
Right.
Because we did the 12 earlier, and then 3 times 3 is 9. So
So 9 divided by 3, how many times 3 goes into 9?
3.
3. And what about 12? We already did this here. We went in 4 times. So we get 3/4 of a net carton. Alright, that's very good, guys. Very good. So what I want you to do now is pick up your white pieces of paper, and you're going to solve 3 problems for me. I want you to work together as partners, and I want you to use egg cartons to help you. And once you guys are finished with solving your problems, I want you to come up to the board, both of you, and write out the problem, and I want you to explain to me how you got the answers. Because after you guys will be finished, I will suddenly forget how to do math. So you guys will have to teach me. And when you're teaching, I want you guys, in your explanation, to use these words: fraction, whole, and denominator. And make sure when you're explaining, these words do make sense. Just not throw them in there. So the first problem for you to solve will be this one. So what I want you to do first is talk to your partner, identify what pieces of egg carton will each fraction represent.
We can use the egg carton again?
Absolutely, yes.
Okay. So 1/2 plus 1/2.
And one thing I forgot to mention, once you're finished with your problem, I want you to write down 2 sentences underneath of each problem explaining how you got the answer.
So I'm just taking 2 halves of our whole, so it's a whole. Put them together.
Then you get the whole egg carton.
I think he's starting us off easy.
I think so. I think he thinks we are 4th graders.
Now Vitaly, tell me, what does this represent? What are those?
Oh, I drew out my egg cartons. It helps me do it a little better if I can actually.
Okay.
Do that
So you use
stuff.
pictures to help you.
Right.
That's very good, very good. How about you, Jesse? Have you done any pictures or you just doing?
Well, I use the egg carton,
Uh-huh.
which helps me a lot, but what I'm confused on is I know if we say 1 over 1 is the same as saying 1.
Mm-hmm.
Is that right?
Yes.
But if we say 1 over 2 plus 1 over 2, or 1/2 plus 1/2, it just doesn't make sense to me how that comes out to 1 over 1.
Well, think about it. What's 1 over 2?
It's half. It's
Exactly.
This piece.
So when you have a half and another half, what do you get?
A whole.
Mm-hmm. And what's the whole?
1 over 1.
Mm-hmm. So don't think about the numbers. Think of it as a half.
Okay. Okay.
Yes.
And once we do this, write our sentences?
Yes, right. At least 2 sentences that include the vocabulary words, fraction, whole, and denominator. Just explaining how you got your answers. And you guys have about a minute and a half.
I know.
You're done with just 1, right? There's 3.
Oh, sorry, I didn't see the
Yes.
others.
So actually, we're gonna do 2 only,
Okay.
because we're kind of short on time.
So
And you guys can work together, remember that. So
which piece was the
you can help
1/3?
each other.
The
We
1/3.
didn't use that yet.
No,
We didn't do that. No.
that's too little. There we go.
Okay, yeah. There we go. That's 3. That's
The 1/4. I use this one for the 1/4.
use this one too.
Yes.
But these still make the same, right? Even though they're different color and shape.
Yes, because there is the
3
3
spaces.
out of 12.
Okay.
So why have you drawn this one with the line in the middle?
Well,
Not
because
full line.
before I was looking at the 1/3, I
Mhm.
thought 3 dots, but then I
Mhm.
go and actually.
So you were able to correct yourself.
Yes.
Very good, very good.
Thank you. No, I want to erase the line. You criticize my
I did not criticize it. I was just curious.
Hmm.
All right, about 30 seconds. All right, and the time is up. If you guys don't finish with your sentences, you can do it after. But right now, I want you to both come up to the board and teach me how you got your answers.
Okay.
Explain to me. Remember, use the vocabulary words so I can see that you guys remember them and understand them.
Do you want to do the first one? I'll do the second one.
Yes. Yes, I can do this.